Hello, my name is Rawan mashal. My schoolmates Muna abu-qtaish, Iman Smadi and I are going to explain the constant gain circles unilateral case. A two-port network is unilateral when S12 equals 0. That means no reflected signal from the output to the input. In a unilateral transistor, gamma n equals S11 while gamma out will equal S22, and the unilateral power gain called GTU is given by these equations. The first term, the gain at the source, depends on the S11 parameter of the transistor and the source reflection coefficient. The second term, G node, depends on the transistor's scattering parameter S21. The third term, the gain at the load, depends on the S22 parameter of the transistor and the load reflection coefficient. Input gain circles are represented by constant circles with centers located at the angle of S11 conjugate. If gamma s equals 1, then the gain at the source will equal 0. If gamma s equals S11 conjugate, then the gain at the source will be obtained from this equation. The maximum gain at the source will equal 1 over 1 minus S11 squared. Each gain will be represented by a circle. To get the center and radius for each circle, these formulas can be used. G and S equals the gain at the source over the maximum gain at the source. If they are equal to each other, then G and S will equals 1. That means the center will equal S11 magnitude and the phase will be at the S11 conjugate. RS will equal 0. That means the maximum gain is represented by a point on the Smith chart. Output gain circles are represented by constant circles with centers located at the angle of S22 conjugate. If gamma L equals 1, then the gain at the load will equal 0. If gamma L equals S22 conjugate, then gain at the load will be obtained from this equation. The maximum gain load will be equal 1 over 1 minus S22 squared. Each gain will be represented by a circle and the center and radius can be obtained from these equations. G and L will equal the gain at the load over the maximum gain at the load. If the gain at the load equals the maximum gain at the load, then G and L will equals 1 and the center will be at S22 magnitude and the phase at S2 conjugate. The radius will equal 0. That means it is represented by a point. Exercise. Design an amplifier with the following S parameters at maximum gain and 16 dB. Here are the S parameters. To do that, we can use the MATLAB calculator. Let's check if it's stable first. Delta is less than 1 while K is bigger than 1. That means it is stable. We open the tab, the Smith chart, draw a line on the S11 conjugate angle, which is 155 here. Draw a line and draw another line on S22 conjugate, which is 20 right over here. Okay. Now let's get the compass. S11 magnitude equals 0.707. Here is 0.707. You have to put it at the origin. And draw a point. This equals S11, which is the maximum source gain. Just want to Okay. Now let's draw S22 magnitude, which is equals 0.51. This is almost here. Okay. Take the compass, put it at the origin, and draw a point. Sorry. Here is S22, the maximum gain at the load. To get a 16 dB amplifier, we have to find G node first. G node equals S21 squared, which is 14 dB. We have 2 dBs left. We have to get one from the source and one from the load. To do that, press on the constant gain circles, write one here, and one here. We obtain the radius of the source and the center also, and the radius and center of the load. To draw them, go back to tab. We have to find the center first. For the source, it is equal 0.55, so it's almost here. Okay. Take it. And put a point on the center. The radius is equal 0.37. And it is almost here. Okay, we take it back to the center and draw a circle. Here. And draw a circle. This circle represents a 1 dB. Now let's draw the output gain circle. The center is located at 48.48. It is here. You have to open it and draw a point from the origin to the center. Here is the center. The radius equals 0.2. We take the compass and find 0.2. And draw a circle. This represents a 1 dB output circuit, gain circuit. Okay, now we have to find a path between these two circles. We can use this path over here to the origin, and then we can use this path over here to this point. We have these points, this one and this one. The first path is anti-clockwise, which means we are adding a series capacitor. This one over here is also counterclockwise, so we're adding a parallel inductor. This one over here is clockwise, so we're adding a series inductance, and this one over here is also clockwise, so we're adding a parallel capacitor. This is a 16 dB amplifier. Thank you for your time.